Hi everyone. In this video, we are going to discuss about the special electrical machines. What is called special electrical machines? Apart from that, conventional electrical machines. We know that conventional electrical machines are AC machines and DC machines. But in the special electrical machines are developed for the some kind of specific purposes. And then stepper motor is the one of the special electrical machines. So the stepper motors, the name will tell you that the rotation will not be in a continuous manner. It will rotate in a step by step motion. And these are all the some of the images of the stepper motors. So variety of stepper motors are available for certain kind of special applications. And normally the stepper motors are widely used in our industrial applications as well as in the machineries. The examples are listed here: the floppy disk drives and flatbed scanners, computer printers, plotters, and even in the slot machines and image scanners, compact disk drives, intelligent lighting, and even in the camera lenses. For zooming applications, we are using the stepper motors. And even in the CNC machines and also in 3D printers. So even that stepper motors are equipped in this robotics also. And the stepper motor, as usual, it is an electromechanical device which converts from electrical power into mechanical power. And it is a type of brushless synchronous electric motor that can divide a full rotation into an extensive number of steps. So as I already mentioned that it is not rotated in a continuous manner, it will move in the step by step motion, or otherwise we call it as discrete motion. The motor's position can be controlled accurately without any feedback mechanism. That means the stepper motors are mostly used in the open loop system. So according to that input, it will rotate. And also it is very similar to switched reluctance motor or variable reluctance motor. The stepper motor uses the theory of operations for magnets to make the motor shaft attain a precise distance when a pulse of electricity is given. And you can see this diagram. In this diagram, the stepper motor has an 8 poles and rotor has 4 poles. And the rotor will require 24 pulses of electricity to move the 24 steps to make one complete revolutions. So the rotor will move according to that input. That means the step angle, the total angle is 360 degree, is divided by 24 pulses. Therefore, we are getting 15-degree movement for each and every pulses. So we are giving a single pulse means it will rotate or it will move up to 15-degree rotations. So there are three main types in the stepper motors. The first one is called variable reluctance stepper motor. Second one is the permanent magnet stepper motor. And third one is the hybrid synchronous stepper motor. The first one, variable reluctance motor, it is used in the most of the applications. The VR type have a plain iron rotor and operate based on the principle that minimum reluctance occurs with the minimum air gap. That means the stator teeth and rotor teeth, it forms a very minimum air gap, therefore provide a minimum reluctance. Then only the maximum flux will be moved between that air gaps, and hence the rotor points are attracted towards the stator magnetic poles. And see that image of the VR type, the variable reluctance stepper motors. So it has a 6 stator teeth as well as the 4 rotor teeth, and the windings are placed diametrically opposite to each other. So there are 3 coils are there. Light blue, thick blue, and the orange colors will show you the 3 coils, 3 set of coils. And here you can see how the rotor is made, the steel laminations. There is no kind of any winding, and it is not even a permanent magnet, just it is an steel laminated core in the rotor. It has 4 teeth. Therefore, stator has 6 stator teeth and rotor has 4 rotor teeth. So this is the diagram, and this position is called as aligned position. When the stator teeth and the rotor teeth are aligned on the same axis, it is called as aligned positions. On the right side, another diagram you will show there are 3 set of coils, which already mentioned that A, B, C. So there are 3 coils, and the center of the rotor axis is aligned with that coil A. So that coil A and the rotor teeth are aligned on the same axis, therefore it is called as aligned position. And now you can see the energization from switching from A to coil B. Now the rotor's teeth is also moved to that respective coil, therefore it is called as step. So now the rotor teeth is moved, it is called as step. So by that way, we can energize the coils in a sequentially manner, A, B, C, like that. If we are switching that energization of the coil, the rotor will rotate in the anti-clockwise direction. Now you can see the C coil is energized, therefore rotor teeth is come to align with that respective coil. So A, B, C. So like that I can move that rotor in the counterclockwise direction. So you can see this, when you are applying a single pulse, it will move an complete rotation or somewhat a single step. If you are providing a one pulse means one step. Furtherly, if you are providing a clock of signals, that means pulse of train. Continuously, if you are giving that pulses, it will give a continuous step-by-step rotation. But these motors are not rotating in a continuous rotations like an conventional motors. And the next type is called as permanent magnet stepper motor. It uses a permanent magnet in the rotor instead of the ordinary steel lamination. So we are providing that permanent magnet over the rotor, and the operation may be either in the attraction or repulsion between the rotor PM and the stator electromagnets. And the third type is called as hybrid synchronous stepper motor. So I can take the best features from the variable reluctance and permanent magnet stepper motors. I can form a new motor. So the combination of the permanent magnet and the variable reluctance techniques to achieve this maximum power in small package size. So it is called as hybrid. Hybrid is nothing but a combining. So the combining of the PM type and VR type will give you this third type called hybrid stepper motor. And this diagram will show you that hybrid stepper motor, the best advantage of that is even we are getting an 1.8 degree step movement. So we can get a minimum step size is also possible in this case. So this is the construction of that center part. It is called as rotor. Rotor, which we are having a permanent magnet. One side is north and another side is south. We are providing two end caps on the both sides of the magnet. Now you can see rotor and stator both we are having 50 teeth. So these teeth are aligned with each other. The teeth are equal, therefore it is aligned with each other in the left diagram, and you can see that right diagram somewhat it is misaligned, that is called as unaligned or off aligned or completely aligned. You can see the teeth of the stator as well as the rotor. Here you can see the attraction type and repulsion actions will be held in this hybrid stepper motors. And the step angle may be 1 by 4 into angular pitch. That means the angular pitch is equal to 360 degree divided by 50 teeth. Therefore you are getting that angular pitch. Somewhat a very close movement will be happened. So the direction of the rotation, how will you change the direction of the rotation? Now you can see the coil S1, the coil S2, the coil S3. So there are three set of coils are there. So one by one I can sequentially energizing. Therefore the first coil S1 is energized, there is no kind of any movement in the rotor, 0 degree. But the second coil is energized, at the same time S1 is switched off. Therefore the rotor will shift to 30 degree, and the S2 will come to off and the S3 will be energized. Therefore we are getting another 30 degree. So totally from the origin it will rotate up to 60 degree. The same thing if we are going to clockwise rotation, it is also possible. So first S3 I am going to energize, then S2, then S1. At the same time the previous coils are switched off. So I can rotate this motor in the clockwise or in the counterclockwise. Now it is called as two-phase on mode. So simultaneously I can energize that S1 and S2 coil and S2 and S3 very next. Therefore I am having that first coil AB is energized, then BC energized, and then CA is energized. So like that I will get a 15 degree, 45 degree, 75 degree, 105-degree movement. It is of course similar to this in the right side. You will notice that it will rotate in the clockwise direction. So either directions you can set by using the sequential of the respective coils. This is called a half step mode. This is another mode. So in this method, the first started with that only one coil. That means A coil only will be energized. Second mode, you are having that S1 and S2. Both the coils are energized, and the third one S2 alone, and the fourth one S2 and S3. So like that, if you are setting that sequence means you will get an 15-degree movement, 0 to 15 degree, and 15 to 30 degree, and 30 to 45 degree. So like that you can minimize the step angles. And the last one S3 alone. Okay, therefore the half step mode will provide you very small step movements. That means you are getting even 1.8-degree movement is also possible. So we have to minimize that. These are the some of the overlapping of this stator teeth and rotor teeth, where it is aligned, how it will aligned changes are switching. So that's why it is called as variable stepper motors. So the advantage of the stepper motors, the rotation angle of the motor is directly proportional to the input pulse. So we are providing that pulse means it will come to rotate. And the motor has a full torque at a standstill. See, so it's a very important point in the stepper motor. Even at a standstill condition, it will give a full torque. And the precise positioning and repeatability of movement, since good stepper motors have an accuracy of 3 to 5% of a step. So that error is a non-cumulative from one step to the next. Therefore, the overlapping of that stepping is not here. Therefore, the precise positioning, when you want to move that motor to 1.2 centimeter, exactly or precisely it will move to the same positions. Very excellent response in this case of when you are going to start that motor, when you want to stop that motor, when you want to reverse that motor. So the excellent response will be having in this another best features of the stepper motor. And it is very reliable since there are no contact brushes in this motor. Therefore, the life of the motor is simply dependent on the life of the bearing. And the next one, the motor responds to digital input pulses provided. It works in the open loop control, making the motor simpler and less costly, because here we are not using the closed loop signals and closed loop devices. And it is possible to achieve very low speed synchronous rotations with a load that is directly coupled to the shaft. A wide range of rotational speeds can be also realized that the speed is proportional to the frequency of the input pulses. The very important parameter of that stepper motor is resolution. The resolution is given by the number of steps needed to complete one revolutions of the rotor shaft. Higher the resolutions, greater the accuracy of positioning of objects by the motor. So what is the formula for finding resolution is number of steps divided by revolutions. So you can find that revolutions beta is equal to 360 degree divided by m into nr. M is nothing but a number of phases and nr is the number of rotor teeth. So another formula is also there for finding that beta is equal to ns minus nr divided by ns into nr into 360 degree. So we can find that resolutions also. And this is the applications of the stepper motors, particularly in the robots, or somewhat pick and drop of these robo mechanisms. So it works in the CNC machines, medical scanners, computer printers, compact disc drives, and even in the digital cameras. So up to this, the introduction to the stepper motors are over. Thank you.